Hi, my name is Blanche Horbach. I have a background in logistics and transportation management, program management, and leadership. I recently graduated from City College with an applied mathematics degree. Everything about me is analytical and data-driven, so I knew that this program at Savvy Coders was the perfect fit for me. I was born and raised in Ecuador. I moved to the United States when I was 18 years old. One of the biggest cultural shock I had was noticing how many people have vitamin D deficiency symptoms and how I started experiencing some of them myself. I also served in the United States Air Force for 7 years and traveled around the world and had the opportunity to experience the heat and UV exposure from many different countries, and I still remain vitamin D deficient. This made me come up with the question, is the vitamin D that we get from our sun and our diet enough? For my capstone project, I examined the relationship between vitamin D added to food products and UV exposure with levels of vitamin D in the population. To ensure that the project progressed efficiently, I organized it into sprints, each dedicated to a specific task, such as data gathering, cleaning, organization, and visualization. Throughout the project, I collaborated with classmates, exchanging feedback and ideas regularly. By adopting an agile methodology, I was able to make rapid progress while remaining flexible to any changes in my project's requirements. The agile approach empowered me to achieve my objectives within the given time frame while maintaining the quality of my work. I also used data analytical tools such as Python, SQL, Excel, Tableau, and statistical analysis. I gathered my data from the British Journal of Nutrition, the World Health Organization, and Open Food Facts. So let's jump into the code. All right, so in one of my data sets, I downloaded it from this link. So I imported requests into Python so that I can work with this. I realized that I have a .gc file. It was compressed, so I have to decompress my file. And for that, I imported the library gzip, which helped me decompress this file. After that, I used the library shuttle so that I can make a copy of my data set in case I make a mistake and I have a backup just in case. After I did that, I imported CSV into my Python and I printed the headers of the name of each column. And then I wanted to see all of them and just pick and choose which one I was going to work with because this data set was really, really big. Already on this part of the code, as you can see, I'm reading the header. So I printed out and they print out over here. And then I found the names of the name of the columns that I wanted to work with, which are countries and vitamin D. And then I printed their indexes. In this case, it was 38 for country and 151 for the vitamin D. And then after that, I imported SQLite3 so that I can work with SQL in my Python. And then here I created a table with those two pieces of information. And then I use, as you can see, I used the indexes 38 and 151. And after I created my table on SQL, I imported pandas so that I can clean my data and I removed null values from it. In this part of the code, this one is, I'm using a different data set. This one, I'm trying to get the data from a .gift or GIF file. And for that, I imported Pillow and NumPy, and then I converted them into NumPy arrays and extracted the table region by setting all of non-table pixels to transparent. And then I saved that pill image back to PNG file. After that, I imported Pytesseract and CSV, and then I loaded the PNG image. I converted the image into grayscale, and I used OCR to extract the text from the image. And I split the text into rows and columns, and then I wrote it into a CSV file. All right, let's jump into the graphs now. And then our first graph, we have the countries that we're going to be working with and the vitamin D in the population. We have here that Argentina is the one with the lowest one, and then the United States is leading. According to experts, anything over 50 is what you're looking for to show that you have good levels of vitamin D in the population. In this next graph, we have vitamin D levels in the food products, and we're using the same countries. We can see that the one with the lowest level in food products is Brazil, and the highest one is the United States. In the next one, we have the UV radiation index average per year per country levels. So we have the Brazil is leading with the highest amount, and we have Poland with the lowest one. In this next file, this graph, I have the three of them. I organize them from lowest to highest so that I can have a better picture. And then here we can see, something like Argentina is the lowest one, but we can also see that Argentina is not the lowest one that has, vitamin D added to their food. And it's kind of like in the middle when it comes to radiation, but still very low. We'll have a more clear explanation of this in the next one with a little bit more color. So here we have the vitamin D food product. So this one is measuring. So the darker the blue means that it has the most amount of vitamin D added to the food products, the ones that you find in the shelves, the aisles of your grocery store. So here, once again, we have the United States, but then we can see something like, Italy here. So we can something like Italy with a 7.6 vitamin D added to the food, but still has, a little bit over that 50 points threshold. And then we have a country like Brazil with a 0.1, but has great amounts of vitamin D in the levels in their population. So let's see the next graph. So in this graph, we have the UV radiation level. The darker it is, the more radiation the country is getting. So here we have, Brazil. You were like, okay, so Brazil, is very low when it comes to the food, but maybe they're getting the vitamin D levels from the UV exposure. That's why they have great amounts of vitamin D levels. But then we see, we can go and see India, who has great amounts of exposure and very low amounts of vitamin D, and also very low amounts of vitamin D added to the food. So, hard to tell any relationship. And then here we see Canada as well with a very low amount of UV radiation, but great amounts of vitamin D in their population. So this graph, we have the countries that allow, and it's mandatory actually, to have additives added to milk, and one of them is vitamin D. So these countries allow it, and then for the ones in red, it's a no. And then we can see, all right, so the ones leading the game are the United States, Canada, and Brazil, maybe because they add that vitamin D to the milk. But then you see a country like Italy that is also up there with them, and they have a mandatory no additives to milk. They don't allow it. So we can see that they still have a high level in their population, even though they don't have any additives to their milk. So now we're going to see the next graph. And this one is, is there any correlation? So I have this, I want you to pay attention to this blue line. This one is the one that we want to correlate with the other two. I organized this from the lowest to the highest, and the blue line is the vitamin D in the population levels. So this is, as you can see, is increasing. It's increasing. What we want to see is something similar when it comes to these other two lines. It doesn't have to be the same, but it has to also increase to have some sort of like correlation. So we can see these two lines are going start high, then they go down, down, up, and then they go everywhere. And according to this data, there is no correlation between UV radiation index and vitamin D added to food with the levels of vitamin D in the population. So take your multivitamins and don't be afraid to wear your sunscreen. Thank you.